In the deep, frozen void of space billions of miles from Earth, a spacecraft built in the 1970s has just accomplished something no one ever anticipated. Voyager 1, the farthest human-made object ever launched, has done the unexpected. It has turned its sensors not outward into the unknown, but back toward Earth, our solar system, and the home it left behind. What it transmitted from that remote vantage point has shaken the scientific community. Engineers are baffled, astronomers astonished, and physicists are questioning long-held theories. This isn't merely about reaching an extraordinary distance from Earth. It's about a fundamental contradiction in the data Voyager 1 sent back, data that challenges our entire understanding of interstellar space. The expected patterns in magnetic fields, plasma waves, and cosmic radiation no longer apply. Until now, all evidence pointed to a consistent model of the space beyond our solar system. But this discovery, unsettling in its implications, didn't come from an advanced satellite with cutting-edge technology. It came from a machine with computing power less sophisticated than a digital watch, one that runs on a slowly decaying plutonium power source, and yet it has whispered back something we never imagined hearing. The question arises, what has Voyager 1 just confirmed? And why does its signal feel more like a warning than a scientific finding? This chapter of Voyager's journey began with a once-in-a-lifetime cosmic alignment, an event that only occurs every 176 years. The unique configuration of Jupiter, Saturn, Uranus, and Neptune made it possible for NASA to launch a probe that could use each planet's gravity as a slingshot, dramatically reducing its travel time across the solar system. When Voyager 1 launched in 1977, it was only expected to function for a few years. Now, nearly 5 decades later, this modest probe, despite its outdated technology, is traveling faster and farther than anything humanity has ever sent into space. Along the way, it captured legendary images and data, sweeping photos of Jupiter's storms, close-ups of Saturn's moons, and measurements that expanded our understanding of the outer solar system. Yet none of those accomplishments compare to what Voyager 1 faces today, because today, it's not just moving through space, it's entering a realm we never imagined observing, a place where the sun's influence fades and a mysterious new domain begins. Voyager didn't simply pass through the heliopause, the theoretical boundary where solar influence ends, it disappeared into it. And what it encountered beyond was far stranger than scientists had prepared for. Crossing into interstellar space was expected to be a clean and predictable transition. The prevailing theories predicted a sudden drop in solar wind pressure, a noticeable shift in magnetic field orientation, and a rise in cosmic radiation. But when Voyager 1 crossed this boundary in August 2012, the data defied expectations. The density of charged particles did increase as predicted, but the direction of the magnetic field didn't change. It remained aligned with the solar field, something that shouldn't have happened if the spacecraft had truly left the sun's domain. It was as if Voyager had stepped through a doorway only to find the same environment waiting on the other side. Then the spacecraft began picking up low-frequency plasma waves, strange, organized oscillations that didn't seem random. They had rhythm, intention, and structure. This mysterious data led some scientists to question whether Voyager had even exited the heliosphere at all. Perhaps, they proposed, the boundary is far more complex or even intelligent than we believed. Years after the initial crossing, Voyager 1's instruments began transmitting signals that didn't fit any known scientific profile. The background plasma noise began fluctuating not from stars, black holes, or supernovae, but from something that seemed to echo Voyager's own transmissions. This wasn't random static, it acted like feedback. Something out there wasn't just hearing. Voyager it was responding, but it wasn't responding in binary code or standard radio waves. It communicated in frequencies and patterns that no human technology had yet defined. The implications were profound. Could the vast, empty void we've always assumed to be silent actually respond to us? Is space itself listening, or worse, is there something embedded within it, aware of our presence? Some researchers began referring to the phenomenon as resonance, a kind of cosmic echo. Others feared something far stranger. Whatever it was, it seemed impossible that it was coincidence. The signals were growing stronger and more organized. And then something unprecedented occurred. Voyager 1 paused. For nearly 2 weeks, the spacecraft's data stream became irregular, not lost, not corrupted, but intermittent, as if something were interrupting or redirecting it. Some engineers dismissed it as a malfunction caused by its ancient software. But when transmissions resumed, the instruments had shifted focus. They were no longer aimed ahead. Instead, they were reoriented, focused on the space behind Voyager, aimed back at the solar system. What it detected from that direction was unsettling: fluctuations in energy levels, sudden surges in particle density, as though something was awakening in its wake. Voyager 1 carries with it the golden record, a symbolic message from Earth, designed to represent humanity to any intelligent life that might encounter the probe. It contains music, greetings in dozens of languages, and images of life on our planet. This record was sent as a gesture of peace and curiosity, a hopeful handshake into the cosmic void. But what if it wasn't simply drifting through space anymore? What if something or someone had found it after Voyager reoriented its sensors? Analysts at NASA began to notice unusual changes in the spacecraft's surrounding electromagnetic field. Patterns started to appear, rhythmic modulations that bore an eerie resemblance to the waveform structures used to encode audio on the golden record. These were not random disturbances. They looked like a mirrored pulse, a kind of response. It seemed as though the message had been heard, and something was responding in kind. Although NASA has not made any official statements, internal reports hint that some scientists fear this attempt to reach out may have triggered something unexpected. We wanted someone to find us, but we never considered whether they would want to. Following this directional shift, Voyager's cosmic dust detector, long thought to be nearly irrelevant at such distances, began logging strange impacts. These weren't the aimless grains of interstellar dust that one might expect. They were dense, frequent, and moving at unpredictable velocities. Analysis showed the particles contained exotic isotopes rarely observed even in our own galaxy. It was as though Voyager had entered a region of space that was not entirely natural. Theories began to emerge. Some suggested Voyager had encountered turbulence caused by dark matter. Others speculated it had passed near an ancient, artificial structure, perhaps long dormant, broken, or waiting. Then came the most inexplicable discovery. After decades of smooth, uninterrupted travel, Voyager's course began to drift. This wasn't due to thruster activity or gravitational interactions. It was a subtle yet consistent deviation that couldn't be simulated or explained without introducing an external force. Something unseen and unknown was pulling Voyager 1 off its projected path. Mission Control was alarmed. If no known celestial body could cause this deviation, what could? And why would it exert influence over a 720-kilogram probe in deep space? Voyager wasn't merely turning its instruments, it seemed to be responding to an invisible summoning. Then, through its last functioning plasma wave sensor, Voyager picked up something else. A drop in frequency, followed by a sudden surge in amplitude. This wasn't interference or static. It was structured, an identifiable profile that matched no known natural phenomenon. It wasn't a pulsar, it wasn't a star, but it had a pattern, a rising and falling rhythm that repeated several times and then ceased. Some likened it to the beat of a heart, others compared it to the reverberations of seismic activity. But all agreed it came from the direction Voyager had already passed through, the same region it had turned back to observe. Was it a signal, a beacon? A trace of something moving through space slowly, silently, invisibly? Whatever it was, Voyager 1, once a simple envoy of Earth, had now become something more. A witness to a reality we never fully understood. And now, perhaps, that reality has noticed us. Voyager 1 was never meant to be a sentinel. It was launched as a messenger, a time capsule of human culture, flung into the stars with curiosity and hope. But now, almost 50 years later, that messenger has looked back not because we commanded it to, but because something compelled it. We once assumed the universe was silent, empty, unaware. But the data Voyager has returned suggests a different truth. It reveals a cosmos where boundaries behave unpredictably, where signals echo without clear origin, and where unseen forces can redirect machines and maybe even fates. The truth is, we never knew what Voyager would discover. We never expected it to last this long. And we certainly didn't expect it to return our gaze not with photographs or coordinates, but with a message of uncertainty, cloaked in distortion and silence. So, what now? We wait, we listen, and perhaps we prepare. Because if Voyager 1 has truly confirmed what many feared, that we are not alone, then our journey into the universe has only just begun.